So learning outcome 1 says draw circuit diagrams to show the correct positions of an ammeter and a voltmeter in a circuit. So this was the circuits that we put together yesterday. And the key idea from this one was that an ammeter goes in series with whatever it is you're trying to measure. A voltmeter goes in parallel. Now, in the next class we're going to do a quick reminder of all the circuit symbols, so if some of these are a wee bit vague to you, don't worry about that. Okay, we'll review that in the next class. So what we had yesterday were 2 bulbs, which we just kind of arbitrarily labelled A and B. And then our ammeter symbol, which is that circle with an A. Right. Whether a circuit's series or parallel, an ammeter will always be in series. A voltmeter will always be in parallel. Okay, so that's quite just factual. You need to learn that. Ammeters in series, right, voltmeters in parallel. We did talk briefly yesterday about the idea. Remember, the ammeter is measuring how much charge is flowing through the circuit. So you want to be in the circuit to measure that. That's why the ammeter's got to go in series. A voltmeter is all about, well, voltage is all about the energy. So it needs 2 connections either side to measure the difference in energy. Right, either side of a bulb. So that's why it needs to be in parallel. And then yesterday we found out from our measurements that in a series circuit, the current is the same at all points. Right? It's just one branch. That's what a series circuit means. There's only one way for the current to go. Right? So you can't have more current at one point than you have another. Right? It's like a train, basically, all joined together, all the carriages. And then our second circuit rule, once again about series circuits that we used yesterday. Right. In a series circuit, the sum of the voltages, or PDs, remember we introduced that phrase, potential differences. And if you add them up, that's what we mean by the sum of, then you would get the supply voltage. Or in a formula, Vs equals V1 plus V2 plus V3. If there's only 2 bits in your series circuit, it would just be V1 plus V2. If there was 5 bits, it would be up to V5, etc. But remember, that formula is not given. You need to memorize either the idea or the formula. Number 4 is what we found today, right? 4 and 5. So this is for parallel circuits. So basically it's the opposite way around for parallel circuits as it is for series. Right? In parallel circuits, it's the current that adds up to the supply and the voltages are the same. So we can write that one as an equation. And then last one. Okay, and I'm underlining there to the supply voltage, because most people can manage to remember that they're equal, but quite often forget that idea that it's equal to the supply voltage.